Guys, so today let's do this 2017 question from Calculus Scholarship. Solve algebraically the system of equations, and that three equations are given to us, right? The first thing is to see if you can see something that gives you an idea where to start. So when I look at this, I can see there is x plus y squared, the z is negative. X square plus y square, z square is negative. X cube, y cube, and z cube is negative. Right? So this can give me an idea of it might be coming from the other side. So like if this was plus z here and we moved it to the other side, then it becomes negative z, right? So that z square, so here that z square must be plus z square this way, and this z cube plus be plus z cube this side, right? Another thing I can see is if it is x square y square, it is 2xy here, and with the cubes is 3xy here. So this gives me an idea that it could be a whole square thing. So here if I say x plus y is equals to 1 plus z, and if I square both the sides, squaring both sides, I will get x plus y whole square plus 1 plus z whole square. And if you know a plus b whole square, the algebraic identities is a square plus 2ab plus b square. So this 2ab is usually this 2xy because it's x and y here, right? So always when you get a question where system of equations, try and find out something as a starting point, because as soon as you get a starting point, it's easy to just start the question and then it keeps happening, the thinkings keep happening, you get the points of where to go from there, right? So now if I expand the bracket, I will get x squared plus y squared plus 2xy, and that is equals to, that's not plus, equals to 1 square is 1 plus z square plus 2z, right? Now let's put it in the form that is given to us. Well, let's put it in the form. I'll erase that because it was just a thinking that I was explaining. All right, I'll take that off just because it's easier to then see. So it's x squared plus y squared minus z squared is equals to 1 plus 2z minus 2xy. So left hand side here, left hand side and left hand side of this is equal, right? So we can say equating, let's name this as a and 2 gives, what is this giving? So the right hand side here, right hand side is equals to the right hand side that we have here. Right, so we can write 1 plus 2z minus 2xy is equals to the right hand side we have here, which is 5 minus 2xy. Right, so now when we solve, we can have 1 plus 2z is equals to minus 2xy. When it goes to the other side, it's going to be plus. So that can be cancelled. You have 5. 2z is equals to 5 minus 1 is 4. Z is equals to 2. So we have already got the value of z. Right? Now let's see the third equation. So the third equation is x cube y cube. So we will again start with the first equation. We'll start with the first equation and cube it this time. All right? Instead of squaring, we're going to cube it. So we have x plus y and is equals to 1 plus z, right? And we are cubing this time. So cubing both sides, we get x plus y whole cube, I don't know why am I writing plus there, is equals to 1 plus z whole cube. So a plus b whole cube formula or identity is a cube plus b cube plus 3ab a plus b. right? So here we will just substitute those things. So we will have x cube plus y cube plus 3xy x plus y, okay, is equals to the same identity goes here. 1 cube is 1 plus z cube plus 3, 1 times z is z, 1 plus z. Right, so that's the identity. Now again, we will try and equate it to the left hand side this, so we can equate the right hand side. So left hand side we are trying to get the same, so we can equate the right hand sides. All right, so we can write x cube plus y cube minus z cube is equals to 1 plus, so that z is used, but the other things are still there. 3z 1 plus z, and this value when goes here will be 3xy x plus y. All right, again we will say equating, let's name this as b and 3, we get, so we will get 1 plus 3z 1 plus z minus 3xy x plus y is equals to 43 minus 3xy. 43 minus 3xy. All right, so now again we will simplify. What we know here is that we know that z is equals to 2. Therefore, x plus y is equals to 1 plus z will be equals to 3, which is 1 plus 2. All right, so these two values we already have, and we're going to put those values back there. So we will have 1 plus 3 times 2, and then the 1 plus z thing we have is 3. So that's times 3 as well. Minus 3xy, and x plus y is equals to 3 as well, is equals to 43 minus 3x times y. Right, so something has been simplified. Now 1 plus that becomes 18 minus 9xy. Let's rub that off. Excuse me. So 9xy is equals to 43 minus 3xy. So here we get 19, take away 43 is equals to minus 3xy plus 9xy. So here we get 24 is equals to 6xy, sorry, minus 24. So xy is equals to 4 or minus 4, right? So now let's see what we can do with all the information that we have. So now we know, or we have, you can write, we have z is equals to 2. Again, x plus y is equals to 3, and x times y is equals to minus 4. All right, so now we will try and find the possible values that can satisfy both these equations, right? So here we can see that possible pairs for x times y is equals to minus 4 are, it could be minus 2 times 2, that's minus 4. Minus 1 times 4 is minus 4, and minus 4 times 1 is also minus 4. Right, so these are the possible pairs that gives us minus 4. But now we need to say which of these pairs gives us 3 when adding together. So when you add minus 2 plus 2, you do not get 3, right? When you do minus 1 plus 4, you get 3. And when you do minus 4 plus 1, you get minus 3. So again, you do not get 3, right? So that is the only pair that works. So we can say that x times y is equals to minus 4. So the pairs are x plus y is equals to 3. Therefore, x can be, all right, so there's two values again. Cool. So if x is, if, not therefore, if x is -1, y is 3, right? If x is, sorry, 4, if x is 4, y can be -1, and both of these are possible, right? Because it is a commutative property. It can be either ways, doesn't matter. And z for each of the cases is 2, right? So these are the possible solutions. Possible values of x, y, and z. Cool. I hope it makes sense. Cool. Have a good day.